Hey guys, this is homework 10.7. This is really just like an extension of what we learned in class today on linear regression models. We're just going to talk about a few other types of regression models. So one type of regression model is, at the top I'm just looking where it says read. So we talked about linear. Another type is exponential, and an exponential equation fit to a set of data is just an exponential regression. It's still kind of like this whole idea of a line of best fit, except now exponential regression wouldn't be a line, it would be an exponential equation or curve, you can think of it as. We talked about exponential equations in the past, and they're written in the form y equals a times b to the x power, where x is the variable, so a and b are actual values. Another type is power regression, a power equation where the exponent has a numerical value and it is not a variable, and it's fit to a set of data. So again, think of this idea of like a scatter plot, and you're trying to choose an equation that best fits that set of data. We write these in the form y equals a times x to the b. So this could be like a quadratic or a cubic or a quartic equation where the exponent has a value. And then another type is logarithmic regression. And a logarithmic equation could be written in the form of log with base 10 or a different base, or it could be a natural logarithm. So we're going to do a few examples together. But let's just start out by looking at these three different types of equations and just naming what they would represent, or like what kind of regression model would best fit this type of graph. So here in number 1, we have a curve that looks like this. This would be a good example of a logarithm or a logarithmic regression. The second one is just an example of a linear regression. And the third one would be an example of an exponential regression. So what's important to look at is just like the curvature. So this is kind of starting around the origin. It doesn't have to start at the origin, but then it's just like increases kind of slowly and then more quickly. The logarithm, remember a logarithm and an exponential equation are inverses of each other. So this equation here is basically just an exponential equation flipped over the line y equals x. Okay, so now let's actually get to an example. Okay, so in example 1, it's giving us the population of Jamestown reported for selected years since 2000. The table below gives these populations. So if you notice, one variable is year, the other one is population. Part A says, using your calculator, determine a best fit exponential equation. This is important, exponential equation in the form y equals a times b to the x, where x represents the number of years since 2000. We talked about a question like this in class today. Number of years since 2000. Y represents the population. Round a to the nearest integer and b to the nearest thousand. So those are definitely important pieces of information also. So I'm going to go back to the idea that x represents the number of years since 2000. So if this year is 2000, then that would be 2 years since 2000. This would be 4 years, 5 years, 7 years, 9 years since 2000. So that's important because that's what I want to put in my list. Okay, so now I'm going to go to stat. Okay, so on that stat, I'm going to go to edit so I can put in this information from the list. Remember, the years are just since 2000, so I'm going to put in 2, 4, 5, 7, and 9. 2, 4, 5, 7, 9. And I'm just going to double check myself that I put everything in correctly. 2, 4, 7, 2, 4, 5, 7, 9. Okay. And then I'm going to put the population in as well. Okay, so let's see, my population, 5, 5, 6, 4. So I go to list 2, 5, 5, 6, 4. Then I have 6, 1, 2, 1. Oops. Delete 6, 1, 2, 1. And then I have 6, 3, 0, 0. And then I have 6, 8, 1, 2. And then the last one is 7422. And again, I always want to just double check that I put everything in correctly. 6812, 6300, 5564. Okay, it looks like everything is in correctly. So now I actually want the equation. So I am going to go to stack, help, and now I'm looking for exponential regression, exponential equation. So I'm looking for EXP red. Here I see it right there. It's a 0 in my calculator. Exponential regression. And I use list 1 and list 2, so I'm just going to put that in. So I do second L1, comma, second L2. And I'm going to press enter. There we go. Okay, so it looks like I have an A value. Now, what's really important is looking at the equation says y equals a times b to the x power. So a is the coefficient, b is the base of the exponent, and x is our variable. Okay, so it's said to round a to the nearest integer. So that would be 5158, since it was 7.9. So I round that 7 up to an 8. And then times b, I'm rounding to the nearest thousandth. So 1.041 to the x power. There's my equation. Okay, let's look at the next part of this question. So the next part of the question says to sketch a graph of the exponential function for the years 2000 to 2050. So equal your window and your y-intercept. Okay, so if I want to actually graph this, then I need to do a few things first. I need to first put the equation that I just came up with in my y equals. So I entered that into y equals, as you can see here. The next thing I need to do is I need to go to window, because it specifically said for me to, it specifically says for me to have from the years 2000 to 2050. So that means my x's should be from 0 to 50. Because I just put the x's in as like in terms of years since 2000. Okay, and then notice my y min and my y max. I put as 5,000, then I put as 75,000 for the y min and the y max. Because if I look at my y values, the smallest one is 5564 and the biggest one is 7422. So I just gave like a comfortable range. So now I'm going to look at my graph. Okay, so now I'm just going to plot what this looks like here. It looks kind of like a line, but we know it's definitely an exponential equation. Okay, the third one, by what percent does your exponential model predict the population is increasing per year? By what percent is the population increasing per year? Okay, so if we look at part C, what percent does your exponential model predict the population is increasing by per year? So to answer this question, you need to remember the way that the exponential equation is set up. So if you remember, if it's exponential growth or exponential decay, then the way we write our equation is we have like some number here, but then we have like 1 plus the rates or 1 minus the rates if it's growth or if it's decay. So we have to be careful. This is clearly growth since it's 1.041. That means that the number 1 was added to some percentage. So 1.041, that means that it was 1 plus 0.041, which then tells us that our percentage or our rate is right here. So 0.041 is approximately 4.1%. Okay? The last part, D. So here's where we have to really use our prior knowledge to answer a question. So it says algebraically determine the number of years to the nearest year for the population to reach 20,000. So we want the population to reach 20,000. So Y represents our population, X was our years. Okay, so I need 20,000 and then equals my equation. 5158 times 1.041 to the x power. I'm trying to determine how many years, so I'm trying to determine x, and x is going to tell me how many years since 2000, so I can just add it on to 2000 when I get x. I'm gonna leave this problem for you guys to finish. Think back how you might solve for x when x is a variable in the exponent. That's all for now, guys. See you tomorrow.